When creating code using Python, we often import packages in order to get the functionality of someone else's code without having to implement it ourselves. For example, we import the package scipy in order to use a function that finds the magnitude of a vector right here. However, packages come in many different versions, which we need to specify when installing them into our computer. And these different versions include certain functions or implementations of those functions. Though we could just use the most recent version of in all of our projects, when we're working with a large code base with many different files and hundreds of thousands of lines of code, it's difficult to update our code whenever a new version comes out for a package. Thus, it is easier to just maintain a specific version of our code despite newer versions coming out. But we might be using one version of a package in one project, like this tutorial project here, but then using another version in a different project. But how do we swap between these two different versions of scipy? Well, we could delete and reinstall the package with a specific version when we need to work on this project versus another project, but that's obviously a big hassle. So instead, we're going to use virtual environments, which is a way to use specific packages and their versions per project and modify them on a per project basis. So I don't need to download and then reinstall scipy for the tutorial project and then download a different scipy for a different tutorial project. A good way to think about virtual environments is through the lens of your current setup. Your computer is an environment that holds packages and specific versions. Now, with virtual environments, instead of using your computer's packages and their versions, we're using a specified virtual environment's installed packages and versions when running Python code. With an understanding of the need for virtual environments and what virtual environments are, we can begin our tutorial using venv, Python's own virtual environment manager.
To complete this tutorial, ensure that you have Python 3 installed on a computer with access to the internet. You should also have access to the command prompt or terminal to manage your virtual environments. If you do not have Python installed, navigate to python.org/downloads on a web browser and install a version of Python. 3.9 or higher is recommended for your operating system. If you already have Python installed, ensure your version is up to date by opening command prompt on Windows or terminal on Mac or Linux and type python version. This shows we have Python 3.12.8 installed. If your version of Python is not Python 3, navigate to python.org/downloads and install the latest version for your operating system. Pip is used for installing libraries and packages. It should come installed with your distribution of Python 3, but you can ensure you have pip installed by performing pip-version. This shows we have pip 24.2 installed. If you do not have it installed, use the following guide to troubleshoot and install pip. The tool for managing virtual environments is called venv. It will come installed with your distribution of Python 3. A recommended but not required tool is an IDE to execute and manage your code, such as VS Code, which we have open now. These tools allow you to effectively use and manage virtual environments. Once you have all of the above requirements, you are ready to move on to the next section. For troubleshooting Python or pip installations, search the internet for relevant guides.
Here's some important safety information to keep in mind during this tutorial. Don't use vulnerable versions of packages. When installing and working with older version packages, it's important to make sure that there are not any vulnerabilities in that version that caused a newer version to be created. For example, version 2.26.0 of the request package can expose information you are sending to attackers. See the following link for more information. Google your package and version with the word vulnerability to check if it's fine to use your package version before using the package in your code. Another thing to keep in mind is ensuring that your computer has enough space. Even though this is called a virtual environment, your computer still downloads all packages you request in your library. So ensure you have enough space on your computer to hold all the libraries you need. Check out how much space each of your packages take up online before downloading.
To begin creating your virtual environment, first ensure you have all the tools from the requirements section. Once you've done that, we can begin by creating your first environment. Inside a folder with Python code, we're going to create our first virtual environment. In the command prompt or terminal, in this tutorial we open the command prompt using VS Code's built-in version, type the following command, python -m venv.venv. The -m defines that we want to run venv, in our case to set up a virtual environment. The .venv establishes the file path to our virtual environment, which in this case is the current folder we are in. For more information about the file path syntax, you can follow this guide for Windows, or this guide for Linux and Mac. You should now see a folder called venv with a bunch of different folders and files inside of it. For this tutorial, you do not have to know what any of these do. Just know this is what houses and controls your newly created virtual environment. Before you install or use packages in your virtual environment, you have to activate it. After creating your environment, you can activate it by typing the following command, .venv /scripts /activate. You'll now see the command prompt is preceded by the virtual environment you are using. You can check that this virtual environment is being used by running where python. This now outputs a file path that has .venv in the path. If you ever wish to stop using packages in your virtual environment, like for example, you want to run code using your computer's packages or a different virtual environment, you can deactivate an environment by running this command, deactivate. Pip is the package manager for Python. It is used to install packages you need in a virtual environment. Pip is normally installed with your distribution of Python. You can ensure that pip is up to date by running python -m pip install --upgrade pip. It should now show that you have pip already installed, and you can check the version by running python -m pip --version. This shows the current version that we're using, as well as our Python version. You can now install packages using pip. For an example, we're going to install the scipy package by running the following line, python -m pip install scipy. It should now run and install the scipy package. To install a specific package, run python -m pip install, then place quotes around scipy == 1.15.1 close quotes. To upgrade packages, you can also use pip. Pip can upgrade packages in place by using --upgrade. For example, to install the latest version of scipy and its dependencies, you should run python -m pip install --upgrade scipy. Now that we've shown you how to install and upgrade packages using pip into your virtual environment, we're going to go ahead and show you how to use a requirements file instead of doing it manually. Instead of installing all packages individually, which can be confusing, hard to maintain, or if you have a lot of packages, time-consuming to sit and run pip install for commands for every single package, you can create a requirements file. Your file should look something like this. All the dependencies in this file are automatically installed by running python -m pip install -r requirements.txt, or the name of your requirements file. It will now go through the requirements file and install all these packages according to the requirements that you've set for them. Ensure the requirements file.txt is in the directory you are executing this command in. Now that pip has successfully installed all of the packages in this requirements file, you know how to use it to automatically install all of your packages.
So now, to conclude this tutorial, we're going to run through all of our steps and set up a virtual environment with scipy installed in order to run this really basic script that we have here that imports scipy. So first, we're going to set up our virtual environment. which is python-m venv.venv. So now we have our .venv folder in our directory. Next, we're going to activate our newly created environment by running -venv /scripts /activate. And now we see that we're inside of our virtual environment. Now we're going to install SciPy by running python-m pip install SciPy. And now that we have SciPy installed in our virtual environment, as we can see in our script here in VS Code, SciPy is still saying that it can't be resolved. And that's because specifically in VS Code, we have to set what environment our code will be running in. So if we click here, and now you can see up here, it recommends that we use our local virtual environment, which we'll do in this case. And so now, as you can see, the error has resolved. It recognizes SciPy as a package that we have installed in our virtual environment. And if we hit the run button up here, it runs the scripts and it prints out the magnitude of the vector. So that completes our entire tutorial from start to finish. Please look at all the references within the description for more information on all the specifics about packages, pip, and so on and so forth. Thank you.